Download this code from codegive.com, link in the description below. Blacklist, a comprehensive guide to brute force prevention with Christos Zoulas' daemon. Blacklist, authored by Christos Zoulas, is a daemon specifically designed to mitigate brute force attacks by dynamically blacklisting IP addresses that exhibit suspicious activity. It acts as a bridge between applications that report failed authentication attempts and the firewall, allowing you to automatically block malicious actors before they can compromise your systems. This tutorial provides a deep dive into Blacklist, covering its functionality, configuration, integration with various services, and best practices. Why use Blacklist? Proactive brute force protection. Blacklist detects and blocks suspicious activity in real time, preventing successful brute force attacks. Dynamic blacklisting. IP addresses are blacklisted automatically based on predefined rules, requiring minimal manual intervention. Integration with multiple services. Blacklist can be integrated with various applications, such as SSH, web servers, and databases. Firewall agnostic. Blacklist interacts with your firewall, example PF, iptables, enftables, to add and remove blocked IPs. Reduced load on applications. By blocking malicious IPs at the firewall level, Blacklist reduces the load on your applications. Flexible configuration. Blacklist offers a range of configuration options to tailor its behavior to your specific needs. Key concepts. Counters. Blacklist tracks various events, example failed login attempts, using counters associated with specific IP addresses. Rules. Rules define the criteria for blacklisting an IP address based on the values of counters. For instance, a rule might specify that an IP should be blacklisted if it has more than 5 failed SSH login attempts in 10 minutes. Reports. Applications report events, example failed logins, to Blacklist. These reports increment the counters associated with the reporting IP address. Blacklisting action. When a rule is triggered, Blacklist adds the IP address to the configured firewall blacklist. Whitelist. Allows you to exempt specific IPs from being blacklisted. Grace period. A delay between detecting suspicious activity and actually blacklisting an IP. This helps to avoid accidental blocking of legitimate users due to temporary network issues. Expiration. The duration for which an IP address remains blacklisted. Installation. The installation process varies depending on your operating system. Here are common methods. FreeBSD, and similar BSDs. Linux, Debian/Ubuntu. Linux, RHEL/CentOS/Fedora. From source. Download the source code from a reliable source, like the OpenBSD ports tree, and compile it following the instructions in the README file. Generally, this involves configuration. The main configuration file for Blacklist is typically located at /etc/blacklist.conf. Let's examine a sample configuration file and explain its components. Explanation of configuration options. Listen on socket path. Specifies the Unix socket Blacklist listens on for incoming reports. Applications report events to the socket. Database path. The path to the SQLite database file where Blacklist stores counter values and blacklist information. Log path. The path to the log file where Blacklist writes its activities and errors. Crucial for troubleshooting. Firewall. Firewall_name specifies the firewall system to use. Supported options include PF, packet filter, Common on BSD systems, iptables, legacy Linux firewall, and enftables, the newer Linux firewall framework. Choose the one appropriate for your system. *pf_table_name** if using pf, specifies the table name in which Blacklistd will store blacklisted IP addresses. You'll need to create this table. Example, sudo pfctlt brute force t add 127.0.0.1, this adds 127.0.0.1 to the brute force table for testing purposes. You likely don't want this in a production environment. *default_expires seconds * the default duration, in seconds, for which an IP address will remain blacklisted if a specific rule doesn't define its own expire value. *rule_name. ** defines a rule that triggers blacklisting. The rule block contains the following elements. *counter_name. ** defines a counter that tracks a specific type of event. The counter block includes *interval seconds * the time interval, in seconds, over which the counter is evaluated. *threshold count * the number of events that must occur within the interval to trigger the rule. *expire seconds * the duration, in seconds, for which the IP address will be blacklisted if the rule is triggered. If not specified, the default _expire is used. *action blacklist * specifies that the IP address should be blacklisted if the rule is triggered. Other actions might be possible in future versions. *whitelist IP_address or whitelist CIDR_block * specifies IP addresses or CIDR blocks that should be excluded from blacklisting. This is crucial for preventing accidental blocking of legitimate traffic, such as internal networks. *grace seconds * specifies a grace period, in seconds, before an IP address is actually blacklisted. This helps to prevent false positives caused by temporary network glitches. *debug true-false * enables or disables debug mode, which provides more detailed logging. Use true for troubleshooting, but false for production. Firewall configuration *. You need to configure your firewall to work with Blacklistd. This is the most critical step, as Blacklistd only manages the list of IPs, the firewall does the actual blocking. Here's how to configure PF, iptables, and enftables. 1. Packet filter, PF, FreeBSD, OpenBSD, Mac OS. * create a table *. * add a rule to your pfconf file, /etc/pfconf. The persist option ensures the table is recreated on boot. The block quick rule blocks traffic from any IP address in the brute force table to any destination. Adjust to any based on your needs, e.g. to any port 22 to only block SSH traffic. Remember to reload your pfconf after making changes. 2. Iptables, Legacy Linux. * create a chain, optional, but recommended for organization. * add a rule to jump to the blacklist chain for incoming traffic on the appropriate interface. * add a rule to the blacklist chain to match IP addresses in the blacklist *. Create the blacklist set. Using ipset you'll need to install ipset if it's not already present, sudo apt install ipset or sudo yum install ipset. * save your iptables rules. * the method varies depending on your distribution. Common methods include sudo iptables save /etc /iptables rules.v4, Debian /Ubuntu. Sudo service iptables save, CentOS /RHEL, uses iptables save. You also need to save the ipset configuration so it persists across reboots. This is generally done with the following command. And ensure that ipset restores the configuration on boot, e.g. by adding @/sben/ipset restore f/etc/ipset.conf to /etc/rc.local before the exit 0 line. 3. Enftables, modern Linux. * create a set, or use an existing one. Enftables uses tables and sets. * add a rule to block traffic from the blacklist set. * save the configuration, important for persistence. And ensure that Enftables restores this configuration on boot, usually handled by your system's init system. Key firewall considerations. * placement of the rules. * ensure your blacklist rules are placed early in your firewall rule set. This allows them to block malicious traffic before it reaches your services. * interface specificity. * specify the network interface, example eth0:0, in your firewall rules to avoid unintentionally blocking traffic on other interfaces. * persistence. * make sure your firewall rules are saved and restored on system reboot. Otherwise, Blacklist's efforts will be lost. Testing. Thoroughly test your firewall rules to ensure they are working as expected. You can use tools like map to simulate network traffic and verify that blocked IP addresses are indeed being blocked. Logging. Enable logging for your firewall rules to track blocked traffic and identify potential issues. Reporting events to Blacklist. Applications need to report events, example failed login attempts, to Blacklist using the Unix socket specified in the listen on configuration. The format of the report is a simple string. For example, here's how to report events from different programming languages. 1. Python ***. 2. Bash ***. 3. C ***. Integrating Blacklist with common services ***. Here are examples of integrating Blacklist with popular services. 1. SSH, using pam_exec.so. * install pam_exec.so, if not already installed. * create a script, example /usr/local/ben/report_ssh_failure.sh. Make the script executable. Configure pam. Edit the ssh pam configuration file, usually /etc/pam.d/sshd or /etc/pam.d/ssh. Add the following line before the auth required pam_deny.so or similar denying modules. This line executes the script whenever authentication fails. The required parameter means that if the script fails to execute, the authentication will still fail, which is what we want for security. Restart SSH. 2. Apache, using a custom module or script. Option 1, using mod_security, recommended mod_security is a powerful web application firewall, WAF, that can be configured to report failed login attempts to Blacklist. Install mod_security and the OWASP core rule set, CRS. The installation procedure varies depending on your distribution. Search for guides specific to your operating system. Configure mod_security to detect failed login attempts. This typically involves creating rules that examine the request headers and body for login forms and authentication failures. Use the exec action in mod_security to execute a script that reports the IP address to Blacklist. The script would be similar to the bash script in the SSH example. Option 2, Using a custom script and Apache logs *, you can analyze your Apache access logs for failed login attempts, example based on specific URLs and HTTP status codes, and then use a script to report the offending IP addresses to Blacklistd. This is a more complex approach that requires regular log analysis. 3. Inks, using a Lua script or a custom module. * using a Lua script, with ngx_http_lua_ module. * install the ngx_http_lua_ module for inks. The installation process depends on your distribution. * create a Lua script, example /etc/inks/confd/report_failed_login.lua. * configure inks to set the failed_login_ cookie when a login fails and call the Lua script. Important *, this example relies on a hypothetical $login_failed variable. You'll need to adapt the inks configuration and Lua script to match your actual login handling logic and how you determine login failures. You must also ensure that the cookie is cleared upon successful login to prevent false positives. Important considerations for service integration ***. Accuracy ***. Ensure that the reports sent to Blacklistd are accurate. Avoid reporting legitimate users or internal services. False positives ***. Be mindful of false positives. Implement measures to reduce the likelihood of blocking legitimate users due to temporary network issues or misconfigured systems. Security ***. Protect the Blacklistd socket to prevent unauthorized access. Only allow trusted services to report events. Rate limiting ** Implement rate limiting on the applications that report events to Blacklistd to prevent them from overwhelming the daemon. Logging ** Enable logging in your applications and Blacklistd to track events and troubleshoot issues. Testing ** Thoroughly test your integration with Blacklistd to ensure it is working as expected. Managing blacklisted IPs ** You can manage blacklisted IPs using the blacklistd command line tool. List blacklisted IPs ** Remove an IP from the blacklist ** Add an IP to the whitelist ** Show counters for an IP ** Starting and stopping blacklist ** Start blacklist ** Stop blacklist ** Restart blacklist ** Check blacklist status Troubleshooting * Check the blacklist log file * The log file /var/log/blacklist.log contains valuable information about blacklist's activities and errors. Verify the firewall configuration * Ensure that your firewall rules are correctly configured to work with Blacklistd. Check the blacklist socket * Verify that the blacklist socket exists and has the correct permissions. Test the reporting mechanism * Use the nc command or a simple script to send test reports to the blacklist socket. Increase the debug level * Enable debug mode in the blacklist configuration file to get more detailed logging. Best practices * Use a whitelist * Add your internal networks and trusted IP addresses to the whitelist to prevent accidental blocking. Configure a grace period * Use a grace period to avoid false positives caused by temporary network issues. Set appropriate expiration times * Choose expiration times that balance security with usability. Monitor blacklist activity * Regularly monitor the blacklist log file and the list of blacklisted IP addresses. Keep Blacklistd up to date * Install updates to Blacklistd to benefit from bug fixes and security improvements. Proper counter naming, use descriptive counter names and avoid special characters for easy recognition. Adjust thresholds, Test various thresholds to minimize both false negatives, attacks missed, and false positives, legitimate users blocked. Advanced configuration and use cases ***. Multiple rules *** You can define multiple rules for different types of events or services. This allows you to tailor the blacklisting behavior to specific threats. Dynamic whitelisting *** In some scenarios, you may want to dynamically whitelist IP addresses based on certain criteria. This can be achieved by creating a script that updates the blacklist whitelist using the blacklistd command. However, be very careful when implementing dynamic whitelisting to avoid creating security vulnerabilities. External data sources You can integrate blacklisted with external data sources, such as threat intelligence feeds, to automatically block known malicious IP addresses. This typically involves writing a script that periodically updates the blacklisted whitelist with data from the external source. Blacklist is a powerful tool for mitigating brute force attacks. By carefully configuring it and integrating it with your services, you can significantly improve the security of your systems. Remember to thoroughly test your configuration and monitor its activity to ensure it is working as expected. The key to success with Blacklist is understanding its configuration options, adapting them to your specific environment, and carefully integrating it with your applications and firewall. Good luck.